my name is Hamid Rastgoo and I'm going to be representing University Putra Malaysia for this year's Material Lecture Competition 2021. So my topic is actually going to be about laser joining of dissimilar materials. And in my presentation, I'm going to be talking about three keywords from the topic itself: laser, joining, and dissimilar materials. Ironically in that order, but reversed. So first of all, we're going to talk about dissimilar materials, what they are and how we can identify them. Then we're going to talk about the different joining methods that have been established throughout time. And finally, we're going to talk about lasers and their role in the grand scheme of things. So without further ado, let's begin. So first off, we're going to talk about dissimilar materials. In order to understand them better, we're going to talk about two key questions here. One, we're going to talk about what are dissimilar materials, and then we're going to talk about what is the purpose of joining them, because as we go along, we're going to understand that it's quite difficult to bond dissimilar materials. So we're going to establish the motivation and inspiration behind it. But first off, we're going to talk about what are dissimilar materials. So in general, materials with different core properties are often categorized as dissimilar materials. For instance, metals, plastics, and polymers. However, it is common for one or two materials within the same group to be categorized as dissimilar materials as well. For instance, we have carbon steel and aluminum. Naturally, these are metals. However, due to the differences in composition, they're often at times very difficult to bond and weld together, which is why they're also categorized as dissimilar materials. So now that we've established what are dissimilar materials, we're going to talk about what is the purpose of joining them. Because these materials are different from a core perspective, they're naturally quite challenging to bond together. However, so there are some key aspects that give us this kind of motivation to pursue this idea. First off, the main idea and the main goal here is to obtain a more desirable combination of properties. And alongside that, nowadays we have emerging trends such as increased performance, lightweighting, and functionality, which demand the use of multi-material hybrid structures like dissimilar materials. One great example is polymer and metal. So on one hand, we have polymer, which is very light. However, it doesn't have a really great strength to body ratio. And on the other hand, we have metals, which are very strong, but they're quite heavy as well. So what dissimilar materials actually does is that now we ponder the question: can we get the lightness of polymers and the strength of metals and combine them into one single entity? Well, the answer to that question is yes, but it's a little bit more difficult than that. In order to understand that, we need to talk about the different methods of joining them. Alright, now that we've established what are dissimilar materials and how important their purpose is, now we can jump into the different joining methods that are used to bond these materials. Now, right off the bat, we can actually divide them into two separate groups. One, we have conventional methods, and the other, we have non-conventional methods. Now, the biggest difference between these two is that conventional methods are mostly used for short-term solutions, meaning that either we're using mechanical fasteners or even adhesive bondings. They're mostly used for a very short amount of time. After some time has passed, either maintenance is needed or we need to reuse them so that we can prolong their life. However, with non-conventional methods, this issue can actually be fixed. Nowadays, we have either thermal fusion joining or even hybrid joining, which has entered the game very recently. But with thermal fusion joining, we can see that so many different branches have been laid out throughout time, even starting with such as friction welding, and nowadays we have high energy beam welding. And naturally, beneath high energy welding, we can find laser joining. Now, when we look at the entire hierarchy of this chart, we can see that laser joining has a lot of weight on its back. And throughout time, we can see how these different joining processes have evolved from conventional methods, which are still used today, but very often so, very rarely used. And to finally, we have laser joining, which uses one of the most latest technology to date to try to permanently weld two dissimilar materials. So through this hierarchy, we can see how these processes have been evolved to their formation that are used today. But with that said, we can finally jump into the main topic that we've been trying to talk about, and that is laser joining of dissimilar materials. Alright, so in this section, we're going to talk about laser joining of dissimilar materials, the main topic of this presentation. So everything leading up to this point right now, we're going to see how lasers are included in joining of very different materials. So in that case, we're going to talk about three different factors. One, we're going to analyze a very brief history of laser joining. Then we're going to talk about the fundamentals of laser joining. And finally, we're going to give a very brief example of how this entire process works in real life. With that said, let's jump into a very brief history of laser joining. So starting from the early 1900s, it was the man himself, Albert Einstein, who first suggested the fundamentals of lasers. However, since he was a bit ahead of his time, it took almost more than 40 years until Dr. Theodore H. Mayman built the first ever laser prototype. And this was towards the end of the Second Industrial Revolution. With transposing into the Third Industrial Revolution, technology advanced way beyond everyone's expectations, which is why at that point many consider lasers as a joining method for similar materials. That's why they started doing experiments on joining metal with metal or plastic with plastic. However, since technology was advancing very quickly, very quickly enough, many suggested the fact that maybe we can use lasers to weld dissimilar materials, which is why towards the end of the 20th century, experiments began on welding dissimilar materials using lasers. And transposing into the end of the 20th century, many industrial corporations started to look very interested in laser welding. That's why they started funding a lot of researches to be done on the topic of laser joining of dissimilar materials. That's why it comes to no surprise that only 10 years after the 21st century, there was a breakthrough in investigating laser welding on a molecular and atomic level. So at this point, laser joining had definitely served its purpose on an industrial level, serving solutions to many industrial companies such as aerospace and automotive industries. But at this point forward, many people start to look at lasers on a much more deeper level, trying to find hidden secrets behind it so that they can maybe enhance their knowledge of materials. That's why in 2014, we were able to identify the main parameters in laser joining. So this was a breakthrough in of its own kind, actually, because what this did is that it solidified laser joining in many different aspects of the different communities. Because at this point, since 2014, any kind of experiments that are done with lasers, either it's laser joining or even cutting, people can always turn to these three parameters. Using these parameters that have been identified, we can easily enhance and signify our final results. And we can play with them to get different types, which is why it's a bit of a breakthrough in its own right as well. However, at present day, because we've entered the fourth industrial revolution, technology has enhanced in kind of software-esque-like materials. That's why laser joining has also joined these new industrial revolutions, and now it's done with in-depth research and analysis on laser welding by using finite element method, which is basically bringing simulation into the world of laser joining. Because there are so many different types of materials that can be done or joined with laser joining, many of these researchers and scientists have brought it into a simulation level, trying to fast track these kinds of experiments to have much more faster and, of course, more precise results. And that basically wraps up a very quick and brief history that we started from the early 1900s with just a fundamentally aspect question proposed by Albert Einstein to today, where laser joining is now being experimented on using software analysis, which is quite significant. With that, we can now transpose into understanding the fundamentals of laser joining. So intriguingly enough, the word laser itself is an acronym, which stands for Light Amplification by Stimulated Emission of Radiation. So what this means is that laser is basically a device which is capable of converting light into focused high energy beams. So to illustrate this, the whole point of lasers is that we have a laser source, which is a huge amount of light source, and all we're trying to do is trying to focus and minimize that light into one specific heat affected zone. This is the whole concept of lasers, where we have light and we're trying to focus that light into one specific spot zone, which will generate a huge amount of energy and heat, thus either joining or cutting or doing many different stuff to different materials. Now, with that said, there's actually three main factors that stands in the fundamentals of laser joining. So when we want to join materials, either it has to have high precision manufacturing. It's mostly used for joining of complex shapes and microparts, and it's also a non-contact process. So long as any kind of high energy beam welding is done that consists of these three main parameters, it's usually identified as laser joining. It's a great nitpick as we go along. Alright, so we're going to go a little bit deep on this segment as we're going to explain one particular example of a laser joining process. Basically, we're going to explain what happens when we light up a laser beam and we point it at two dissimilar materials which are overlapped one to another. So naturally, there are different types of joining methods in laser joining. In this case, we're going to take a look at laser transmission joining between polymer and metal. So in this case, we have a layer of polymer sitting on top of a metallic material. What happens when we turn on the laser? So right at the beginning, the laser beam passes through the polymer and irritates the metal surface. So at this point, we can see that the laser has turned on, and since the polymer is on the top of the metal, it will start to melt that polymer as it passes through it. Going to the second stage, the polymer is heated up and bubbles are formed. So these bubbles will actually have a significant impact. Well, we'll talk about that in the third stage. So while the polymer is heating up, bubbles are joined because they've reached the boiling point of that polymer. So that's why it's important the type of polymer and the type of metal that we choose, because the boiling point of that polymer has to be much less than the boiling point of the metal that is beneath it. So at this point, the polymer, which resides on the top of the metal, is now boiling up and bubbles are being formed around it. In the third stage, these bubbles push the molten polymer onto the surface metal, thus kind of liquiding over that metal surface. So because it's past the boiling point of that polymer will start to melt. At least the area that laser is affecting it will start to melt. Once that part starts to melt and bubbles are completely coming around that kind of heat affected zone, the molten polymer will start to cover up the metallic part. And what will happen is, at this point, we're actually kind of done with the laser. Once the polymer has completely covered the metallic surface, the laser shuts down as we no longer need it anymore. It's done its job. So what happens now is that because the room temperature is now much more cooler than the temperature surrounding the two materials, the molten polymer starts to solidify. And once it does that, the bubbles remain on the upper side. So because it starts to solidify, the vaporness around it goes away, and that polymer not only solidifies itself back into a solid form, but while it solidifies, it also hardens its grip around that metallic material. And thus we have a kind of overlap material between polymer and metal, which are now almost permanently completely locked together. And this is just a very basic definition of what happens when we laser join two different materials. Alright, just to give a quick recap, throughout the presentation, we talked about what are dissimilar materials and how we can identify them. Then we talked about why is it important that we combine these different materials, what kind of purpose they have, and how they can extract our needs. Then we talked about the different joining methods surrounding dissimilar materials and how we can bond them. All of this leading up to laser joining of dissimilar materials. And yes, on the surface, the whole topic of laser joining of dissimilar materials is about trying to weld or bond two very different materials using a high energy beam welding. However, on a much more deeper and intellectual level, this topic is actually about understanding the relationship between the materials themselves. because laser joining is only a method to weld different materials. In order for this to happen, we need to have very high understanding of the two materials themselves, and this can only happen while understanding the materials on a much more deeper and a groundbreaking level. What laser joining does is, yes, it will potentially help us to weld two very different materials so that we can use them in very industrial properties. However, what many researchers are following up on this topic, and why it's being researched much more thoroughly and much more deeply today, is because with laser joining, when we heat up a surface of two different, very, very different materials, we start seeing its physical and chemical properties changing. And thus, very different and very hidden meanings and secrets of these materials are kind of unraveled when we heat up these kind of materials. And that is the beauty of laser joining, is once we go much more deeper into the whole aspect of it, we start to find secrets regarding these materials that we've actually never noticed before, which is why we're constantly reviewing these kinds of researches, and why we're going deeply into researching and analyzing what happens when we laser join two different materials. And once we start seeing their physical and chemical properties change, that's when we find so many new and interesting things about them, as we unravel so many hidden secrets of materials themselves. And with that said, I would like to end my presentation, and thank you all for listening.